Welcome back to Talk Tensors. We always like to dig into the latest machine learning research.
Always exciting to see what's new.
And today we've got a paper that caught our eye about making those AI-generated videos even better.
Yeah, it's called Improving Video Generation with Human Feedback.
Okay, so right off the bat, human feedback, that's interesting. Like, we're teaching the AI to be more...
Well, it's about aligning the AI's output with what we humans actually find appealing.
Makes sense. AI is getting good at making videos from, like, PEX prompts, but...
But they can be a little off sometimes, right?
Yeah, sometimes it's like watching a robot try to make a movie.
Yeah.
You know what I mean? It's like...
glitchy, maybe?
glitchy, yeah, or the movements are weird, or it just doesn't quite match what you had in mind.
Right, like you give it a prompt, like a dog playing fetch on the beach.
Classic example.
And you end up with something that vaguely resembles a dog, but the motion is all jerky and the background's blurry.
Yeah, it's like the AI is still learning the nuances of what makes a video feel natural and engaging.
Exactly, and that's where this paper comes in. They're trying to bridge that gap.
Okay, so how are they doing that? What's their secret sauce?
Well, they started by creating this massive data set.
Massive? How massive are we talking?
182,000 human-rated videos.
Wow, okay, that's a lot of videos. So they're basically crowdsourcing human judgments about what makes a good video.
Yeah, they had people evaluate these videos across three main things: visual quality.
Okay, makes sense. Gotta look good.
Motion quality, because we don't want that jerky movement.
Right, gotta be smooth.
And then how well the video actually matches the original text prompt.
They call that text alignment,
Yeah.
right? Making sure the AI is actually understanding and following the instructions.
Exactly. And they use all this data to train a model they call video reward.
Okay, video reward, catchy name. So what does this model do?
Well, it learns from all those human ratings, and then it can predict how a new unseen video would be rated by humans.
So it's like an AI film critic. It's learned what humans like and don't like.
Yeah, you could think of it that way. It's learned to predict human preferences.
That's pretty cool. But it's not just about identifying good and bad videos, right?
Right. The real innovation is how they use video reward to actually improve the video generation process itself.
Ah, okay. So they're using this AI critic to guide the AI filmmaker.
Exactly. Now, this paper focuses on a specific type of video generation system. It's called rectified flow.
Okay, I'm not familiar with that one. What's rectified flow all about?
It's a technique where the AI predicts how pixels should move from one frame to the next.
So it's like choreographing the movement of individual pixels.
Yeah, you could think of it that way. It's about creating a smooth and realistic sense of motion.
Okay, so they've got this video reward model that knows what humans like, and they've got this rectified flow system that's creating the video. How did they bring those two things together?
Well, they took three existing algorithms and they adapted them to work with these flow-based systems.
Algorithms, huh? Sounds complicated.
A bit, yeah. But essentially, they're using the human feedback from video reward to guide the flow of pixels.
Okay, so it's like having a team of expert editors giving real-time feedback to the AI during the video creation process.
Yeah, you got it. They're saying, hey, this transition is a bit jarring, let's smooth it out. Or this scene needs more dramatic lighting.
So it's not just about generating videos that look good technically.
It's about making them resonate with us humans.
It's about that feeling you get when you watch a great video, the emotion, the story,
Well,
the overall impact.
Exactly. And before we dive into the results and the specifics of how these algorithms work.
Yeah, let's take a step back. I think it would be helpful to look at the history of AI video generation. How did we get to this point?
Oh, absolutely. It's been a fascinating journey.
Like, I remember those early AI videos. They're pretty rough around the edges.
Oh, yeah. Very short, low resolution.
And you could always tell it was AI generated. It just didn't have that natural look and feel.
Right. It was missing that human touch. So what were some of the key breakthroughs that led us to where we are today?
Well, I think the development of diffusion models was a huge leap forward.
Oh, yeah. Diffusion models were a game changer.
They allowed for much higher quality and longer videos. And then, of course, there was the arrival of Sora.
Oh, yeah. Sora really shook things up.
Suddenly, it felt like AI could create photorealistic videos that could rival professionally produced content.
It was a turning point for sure. And then models like Dramina Luma and Kling emerged.
Right. Each one pushing the boundaries a little bit further.
Exactly. Refining the technology, creating more sophisticated and visually stunning videos.
But even with all those advancements, there was still this gap between technical proficiency and artistic expression.
You're right. A video can be technically perfect, but still lack that special something that makes it truly engaging.
And that's where this paper comes in, right?
Right. They're trying to close that gap by incorporating human feedback and preference alignment.
It's not just about making AI-generated videos look good. It's about making them feel right.
It's about capturing that human element that makes a video truly captivating.
And I think that's a perfect place to pause for now. We've set the stage, explored the history, and in the next part, we'll dig deeper into the specifics of this research.
Sounds like a plan.
Stay tuned, folks. Things are about to get even more interesting.
Welcome back to Talk Tensors. Before the break, we were talking about this research team training AI to generate videos that are, more in line with what humans like visually.
Right, using those algorithms adapted for these flow-based video generation systems.
Exactly. And I think it'd be interesting to unpack those a bit more, see how they work in practice.
Yeah, definitely. What makes each of these algorithms unique?
So each algorithm tackles the challenge of aligning those AI-generated videos with human feedback in a slightly different way.
Okay, so let's break them down one by one.
All right, so first up, we have DPO, which stands for Direct Preference Optimization.
Okay, direct preference optimization. So it's all about getting straight to the point.
Pretty much. It directly optimizes the model based on those predicted human ratings from the video reward model we talked about.
So basically, it's trying to find these sequence of pixel movements that'll lead to a video scoring high with human preferences.
Exactly. It's like the AI is constantly checking in with video reward, asking, hey, am I on the right track? Will humans like this?
So it's like a feedback loop. The AI is learning from its mistakes and constantly improving based on human input.
Exactly. And as it turns out, the version of DPO adapted for this flow-based system, Flow DPO, was the most successful.
Flow DPO, the champion, huh? What made it so special?
Well, it consistently produced smoother, more visually appealing videos that were better aligned with the text prompts.
Okay, so Flow DPO is the top dog. What about the other algorithms? Did they bring anything unique to the table?
Oh, absolutely. So next up, we have RWR, which stands for Reward-Weighted Regression.
Reward-weighted regression. Interesting name. So how does this one differ from DPO?
Well, unlike DPO, which is all about finding the absolute best solution, RWR is more probabilistic.
Probabilistic. What does that mean in this context?
It means that instead of just searching for the single best option, it explores a wider range of possibilities, weighing them based on predicted human feedback.
So it's like RWR is a bit more experimental, a bit more willing to take risks?
Yeah, exactly. It's looking for those hidden gems that a purely optimization-focused algorithm might miss.
Okay, so we have DPO, which is very goal-oriented, and RWR, which is a bit more exploratory. What about the third algorithm?
Ah, yes. The third one is NRG, which stands for Normalized Reward Gradient.
Normalized reward gradient. Got it. So what's NRG's superpower?
NRG is all about controllability.
Controllability, so like giving the user more options.
Precisely. With NRG, users can adjust how much emphasis is placed on each of those quality dimensions. Visual quality, motion quality, and text alignment.
Ah, so it's like having a set of dials or sliders where you can fine-tune the video output.
Exactly. You could say, hey, I want the motion to be super smooth, even if the visuals are a bit less detailed, or vice versa.
So it's like giving the user more creative freedom to tailor the video to their specific needs.
Exactly. And that's pretty unique, I think.
It is. But, these algorithms are specifically designed for text-to-video generation, right?
Right. This paper focuses on that.
But there are other ways to generate videos, right? Like using a series of images or even manipulating existing footage.
Oh, absolutely. There are tons of different approaches.
But it seems like this idea of incorporating human feedback and aligning with preferences could be applied to those other methods too.
You're absolutely right. It's a fundamental concept that could really revolutionize the entire field of AI video generation.
So it's not just about text to video. It's about making all AI-generated videos better, more aligned with what we humans find engaging.
Exactly. And that's one of the most exciting aspects of this research. It has the potential to be incredibly impactful.
It does. But of course, with any new technology, there are always challenges and limitations, right?
Of course, there are no silver bullets.
So what are some of the potential pitfalls with this approach? Where could things go wrong?
Well, one issue the researchers pointed out is the potential for something called reward hacking.
Reward hacking. Sounds ominous. What is that exactly?
So basically, since the AI is trained to optimize for a specific reward, which in this case is the prediction from video reward, it might learn to exploit loopholes or find shortcuts to get a high score without actually producing videos that humans genuinely like.
So it's like the AI is gaming the system, figuring out how to cheat on the test without actually understanding the material.
Yeah, it's a valid concern, and researchers are working on developing more robust reward models that are less susceptible to manipulation.
That makes sense. But besides reward hacking, are there any other limitations?
Well, another limitation is that the research relies on a fixed set of quality dimensions, visual quality, motion quality, and text alignment.
Right, but those are just a few aspects of what makes a video great. What about things like emotional impact, storytelling, humor?
Exactly. Those are much harder to define and measure, but they're crucial elements of human video creation.
It's like trying to quantify the magic of a movie. It's just not that simple.
Right. And incorporating those more subjective qualities into the feedback loop is a major challenge for future research.
Yeah, that'll be interesting to see how they tackle that. And of course, we can't forget about the issue of data bias.
Oh, absolutely. Data bias is a huge concern in AI.
If the data sets used to train these models are biased, then the AI will just perpetuate those biases.
Exactly. And that could lead to all sorts of problems.
So we need to make sure that those data sets are diverse and representative, capturing a wide range of human perspectives.
Absolutely. Otherwise, we risk creating AI that has a very limited and potentially harmful understanding of what makes a good video.
It's like training a chef on only one type of cuisine. They might become a master of that style, but lack the ability to appreciate other culinary traditions.
Exactly. We need AI that can be a master of all styles of video creation, capable of understanding and embracing the full spectrum of human storytelling.
And this research, with its focus on human feedback, is a step in the right direction.
Absolutely. It's laying the groundwork for a future where AI can truly enhance and expand our creative capabilities.
Okay, so we've talked about the problem, the solution, the historical context, the limitations and future directions. Now it's time for our favorite segment, novel notions.
Ah, yes, the time for unbridled speculation.
Exactly. So building on this idea of human feedback and preference alignment, what if we could train AI to not just generate videos, but to actually understand human emotions?
Whoa, that's taking things to a whole new level.
Like, imagine an AI that can analyze a script and say, okay, in this scene, we want the audience to feel a sense of awe and wonder, and then use that understanding to guide the video generation process.
That would be incredible. It would be like having an AI that's not just a director, but also a master manipulator of emotions.
It could revolutionize fields like advertising and marketing, allowing for hyper-targeted campaigns that evokes specific emotions in viewers.
But of course, with that power comes a lot of responsibility. We need to be very careful about giving AI that level of control over human emotions.
Absolutely. It's a reminder that as we push the boundaries of AI, we need to be mindful of the ethical implications as well. Yeah, it's a slippery slope for sure. But, let's put the ethical concerns aside for a moment and play with one more novel notion before we wrap up. This one's a bit out there, so buckle up. What if we could create an AI that can dream?
Dream. You mean like literally generate videos based on what's happening in someone's mind while they're asleep?
Exactly. Like, imagine connecting an AI to a brain-computer interface and training it on brain activity during REM sleep. Actually turning those dreams into visual content.
Whoa, okay, now we're talking. That's like diving into the subconscious, the world of imagination and dreams.
Right. It would be like opening a window into the most bizarre and surreal parts of the human mind.
The artistic possibilities are insane. Imagine films, music videos, even virtual reality experiences, all inspired by the raw, unfiltered creativity of dreams.
It would be a whole new genre of art, like a fusion of human consciousness and AI.
It would definitely challenge our understanding of creativity and art, for sure.
No doubt.
Yeah.
But of course, the technical hurdles are pretty massive. We're talking about decoding brain activity, understanding how neural signals translate to sensory experiences, and then finding a way to represent all of that visually.
It's a monumental task, but hey, who knows? Maybe someday with advancements in neuroscience and AI, we might actually be able to crack the code of dreams.
It's a fascinating thought. It really speaks to the boundless potential of AI, not just to mimic human abilities, but to push beyond those limits and explore uncharted territories.
Absolutely. And on that note, I think it's time to wrap up our deep dive into this incredible research.
Yeah, it's been quite a journey exploring the world of AI video generation, from those early clunky attempts to this amazing potential for human-AI collaboration.
We've covered a lot of ground today, from the nitty-gritty details of those algorithms to the philosophical implications of AI understanding and even manipulating human emotions.
And of course, we had some fun speculating about the future with our Novel Notions segment.
Always a highlight. So for our listeners out there, if you're interested in learning more, be sure to check out the full paper. We'll have a link in the show notes.
And as always, keep those minds curious and stay tuned for more exciting explorations of the ever-evolving world of AI.
Until next time, keep learning, keep questioning, and keep pushing the boundaries of what's possible.